Okay, this video I just want to cover one application of completing the square, and it's going to be when we're trying to solve for coordinate points, intersection points for a line and a circle. So if we let this be the circle around the origin with radius 1, the equation is going to be x squared plus y squared is equal to 1. And then we're going to let this line go through this point -1, 0, which gives us, so we know that it's going to have this part of the equation, x plus 1, in parentheses around the x variable. And then our slope can be pretty much anything we want it to be, but here I'm just going to let it be 1/4. If we did let the slope be a parameter, or if we just let it be arbitrary for any number, then we could represent it as some parameter t. And this is going to be another video that I do that it's going to be exactly the same as this, except our slope is going to be t, and then we're going to solve for x in terms of t, and we're going to solve for y in terms of t as well. Here I just solved for x, the two x coordinates, and I didn't solve for the y coordinates. But if you can see, one of our x coordinates that we solved for is -1. That makes sense because we know that this line and the circle have an intersection point at -1, because that's kind of how it was constructed. And then the other question is, where is this other intersection point? So that's what we did completing the square for. So basically, I solved for y in terms of x, and then I substituted into the equation of a circle, and then we solved for x. And so to do that, we're going to have to complete the square. So there's a lot of algebra here, but all of this is just completing the square that we've gone over before. And I'll have to check and make sure that it's not too small to read, but hopefully it's not. And then this side over here, this is kind of a glimpse into what I'm going to do with this completing the square later. It's going to be the intersection of a line and a circle, but we're going to have the parameter t be variable so that we can choose t to be what we want. And as you're going to see, if we choose t to be a rational number, we're going to get rational numbers out for sine and cosine here, which actually I could, instead of sine and cosine, I could just write y and x, and then this would be the point xy. So I could just write that, and then we could see that. I don't know if you guys know very much about rational numbers, but if I put a rational number into this equation and this equation, I'm going to get another rational number out. And same here. So that was my main point, is that this is a way that we can parameterize the unit circle into two other functions. And this was kind of just an example, and then I'll show the more generalized form in another video.